The purpose of this third video is to clear up a misconception that a lot of students have when they take physics. And the misconception is this: students hear the term positive acceleration and they think speeding up. And then students hear the term negative acceleration and they think slowing down. Let's just attack this misconception right now. Positive and negative acceleration have absolutely nothing at all in any way whatsoever to do with speeding up or slowing down. And the purpose of this video is to then answer the question, well, so when we say something as positive acceleration or we say something as negative acceleration, what does that mean? And we're going to actually look at an example, look at some graphs and some numbers to really explain what positive and negative acceleration means. So what we're going to do in this video is we're going to tie the ramp lab together with the graphing video that we did in the previous video. So with this demo, here's what's happening. You're going to see a sphere move to the right, and it's actually starting off with a positive velocity. So it starts off with a speed of the velocity of positive 8 meters per second, and it moves right. And then here it stops, and it turns around, and then it actually goes backwards until it reaches its initial point right here. And since it's going in the opposite direction, it's going to actually have a velocity of negative 8 meters per second. Again, sign matters. Now, the goal of this video basically is the following. We want to go from seeing the motion to being able to draw a graph of position versus time, velocity versus time, and acceleration versus time. We want to be able to draw those three graphs. Okay, that's the first thing. And then we also want to be able to go the other way. So given position versus time, velocity versus time, and acceleration versus time, you should be able to tell me what the object is doing. So that's kind of our goal for this video. And we're going to do that by looking at the motion of this sphere here. As the ball moves to the right, you see the position curve rise, the ball slows down, turns around, and then the position curve falls with respect to time. The ball moves to the right with a large velocity, and it slows down, so you see the curve cross the x-axis as it stops. It turns around and gains speed in the negative direction. As the ball moves to the right, it would make sense that the acceleration graph is negative since it's slowing down. But what's weird is that it stays negative as the ball speeds up. We want to explain why. So we have our three sketches here of position versus time, velocity versus time, and acceleration versus time. And our goal is to understand how the motion that we just saw can actually produce these three graphs. So I think the first sketch is actually pretty easy to get based on what we know from the buggy lab and the ramp lab. So for example, we notice here we have this very steep slope, and then here the slope gets less steep. I mean, what we can say is that a steep M and here less steep, and I'm using the term M for slope, so M is kind of an abbreviation for slope. We can clearly say, we can remember that less steep equals slower. And then we can go say, on the trip back down, we can look and say, oh yeah, and as we go back down, we go from here to here. We have, it's less steep as well. And then it gets more steep as we go backwards. So we're gaining speed as we go backwards. So it looks like the motion matches what we saw with the actual movement of the real object. Again, steeper here, steeper here. It's faster, so it goes really fast, covers a lot of distance in a small amount of time. And then less distance and time, stops, turns around. And so we see that kind of makes sense. Same for the velocity graph. If you notice, we start off with a large positive velocity. And then as we move, this also matches our expectations for the ramp lab. We have less of a positive velocity. And then finally, we stop here at 2 seconds. And what happens is these negative numbers here, if you look at the negative signs here, what this means is that we are gaining speed, but we're gaining speed in a negative direction. So the speed gets bigger, and we can see that because the absolute value of the velocity gets bigger. And so we see this going faster and faster. And so what's happening here is, in this part, we are slowing down. And here, we're speeding up. And if I wanted to get a little deep, what I would say is, on this part of the graph, we are losing positive velocity. And then we stop. And then here, we start gaining negative velocity. Now, based on this and this, we're finally ready to understand what's happening. So what I'm going to do is I'm going to kind of match this graph to this acceleration graph to show you. So right here where I'm drawing this dotted line, this is where we stop. Now let's be clear. From here to here, we said that we are losing positive velocity. And from here to here, we said that we're gaining negative velocity. So apparently, I'm just going to say it first, and then I'll try to explain it a little deeper in a second. Okay, losing positive velocity. So in other words, slowing down in the positive direction and gaining negative velocity. That means speeding up in the negative direction. Apparently, both of these things right here mean the same thing. And what they mean, both of these things here, both mean negative acceleration. So what that means is our new definition, our new idea of negative acceleration is something has negative acceleration when we're trying to get it to go in the negative direction. Because if you look, if you're going this way and I'm slowing you down, losing positive velocity means the acceleration is trying to make the object go negative. And when we're gaining negative velocity, it looks like we're succeeding in doing that. We're succeeding in making the object go negative. And that's a deep idea. I would recommend you actually stop the video right now and re-watch this part like 3 or 4 times. So we're succeeding in making the object go negative. So when we slow down in the positive direction, we're going positive, but this acceleration is trying to force us to turn around. So it slows us. So I go really far, and then a little less far, and then less far, and then less far, and finally I stop. I can't go any further in the positive direction. And then what the acceleration does is it gets me going, so going this way, this way, this way. And then what happens is the acceleration turns me around, and I go faster and faster and faster in the opposite direction. So either in this case or this case, the acceleration is trying to get me to go backwards. So to really determine the sign of the acceleration, the question you ask yourself is, which way does acceleration try to get me to go? So in a strange sense, it almost seems like the acceleration is trying to get the object to do something. It's not where is the object going. That's not acceleration. Acceleration is what does the acceleration try to get the object to do. That's a very deep idea. And it's such a deep idea that we're actually going to expand this idea in our next unit when we get to, actually the unit after this, when we get to forces. and we'll talk about what make acceleration happen. But for us right now, what acceleration is negative acceleration means I'm trying to get you to move in the negative direction. Positive acceleration means I'm trying to get you to move in the positive direction. That's a deep idea, and we're going to discuss it quite a bit more in class.